Welcome back to the Introduction to Networks by Cisco course. This is the Module 2, and if you would like to look at the Module 1 video, I will leave the link in the description, and it is already posted on my YouTube channel. In this module, we will look at basic switch and end device configuration. Any videos and associated labs in this module are removed from this particular video. However, I will add those links below so that you can go ahead and watch them to learn how these configurations work. Let's go ahead and look at our module objectives. In this module, we will learn how we can implement initial settings such as passwords, IP addressing, and default gateway parameters on a network device such as a switch. We will learn Cisco IOS Access, iOS navigation, command structure, basic device configuration, save configurations, port and addresses, and how you can configure IP addressing and how we can verify connectivity. Let's look at Cisco IOS Access. The Cisco IOS Access is a type of operating system. The Cisco IOS is basically kind of an operating system that is operating on Cisco devices. Before we understand how operating systems work on Cisco devices, in this case iOS, let's look at the components of the operating systems. We have the shell, which is the user interface that allows users to request specific tasks from the computer. These requests can be made through either CLI or GUI interfaces. GUI is the graphical user interface that you interact, such as even on your Windows machines. CLI is like the command prompt on your Windows machine. But in Linux, for example, it would be the terminal versus having that graphical user interaction modules. I sometimes describe the shell like an animal shell. Shell is the most outside part of the operating system configurations, and it protects the kernel and the hardware, just like a shell that and the animals use to protect themselves. The next one is the kernel. The kernel facilitates the communication between hardware and software of the computer, and it manages how the hardware resources are used to meet software requirements. So you can look at kernel as a intermediary thing between the shell and the hardware. And finally, the hardware is the part of the computer that includes electronics and physical components. This could be a computer, and in this particular course, they are mostly routers and switches. So let's look at what is a GUI. A GUI allows the user to interact with the system using environment of graphical icons, menus, and windows. A GUI is more user-friendly and requires a less knowledge of the underlying command structure that controls the system. And examples of GUI could be Windows, Mac OS, Linux KDE, the Apple iOS, Android, etc. However, the GUI can fail, crash, or simply not operate as specified. For these reasons, having a GUI on network devices are not very ideal. And instead, we use the CLI. And remember, the GUI, what it's all doing is basically giving the user an easy interface to interact with the computer instead of doing all the commands through CLI. So whenever you click on an icon or an item on a GUI, it's basically executing the CLI commands behind the screen. Let's look at the purpose of an OS. PC operating systems enable a user to do the following: use a mouse to make selections and run programs, enter text and text-based commands. The CLI-based network operating systems enable a network technician to do the things that they need to do, just like a user who is using a PC but in this case, a network engineer or technicians using the Cisco devices get the opportunity to interact with the device using the CLI instead of the GUI. The CLI that we use on Cisco devices use a keyboard to run the CLI-based network programs, use a keyboard to enter text and text-based commands, and view output on a monitor. And a typical CLI looks just like this. This is shown on the right-hand side. And the GUI, you guys have, most of you are familiar with what the GUI look like on the left-hand side. So on Cisco IOS, how do you access the CLI? Whether it's a switch, router, or a access point device with some configurations in it. There are a couple of ways to access the Cisco IOS: console, SSH shell, or the telnet. The console provides out-of-band access to Cisco device. A typical physical management port used to access the device in order to provide maintenance, such as performing the initial configurations. Just to give you a heads up, the out-of-band access in IT industry means basically you can access the device even before doing the initial configurations, such as the IP addresses and port forwarding and other port configurations, which you need to have in order to do the SSH and telnet. So the console is the one that is initially used by all network engineers and technicians to set up a Cisco device. The console cable look like this on the right hand side. It'll have the console port connections on here and a connection using RJ45 type connector on the other end, which you can connect to your laptop or a desktop to access your Cisco device. So the Cisco device goes on here and your computer goes on this side. The next one is the secure SSH or secure shell. SSH is an in-band connection and is established a secure remote CLI connection to a device through a virtual interface over the network. This is the recommended method by Cisco as well as other IT professionals because it provides remote connection to your Cisco devices with a secure line. The SSH access can be done through a program such as PuTTY, and it looks like this on the right hand side. And once you enter your information here and you press connection, like when you connect to it, it'll give you this the SSH window where you can interact with your Cisco device. Telnet is a little bit of older program connection type. It is also an in-band connection. It establishes, however, an insecure remote CLI connection to a device. Even though both SSH and Telnet allow over-the-network connections, remote connections to the device, the user authentication passwords and commands sent over the Telnet is not encrypted the way that it is encrypted in SSH. They are all sent in plain text, and typically on most Cisco devices, the Telnet is basically disabled. You can enable Telnet for testing purposes, or you enable it for a short-term basis, because in general, in the industry, we always use SSH over Telnet. The terminal emulation programs, programs that are used to connect to a network device by either a console port or by SSH or Telnet connection. There are several terminal emulation programs to choose. As I mentioned before, the PuTTY, and the other one is Teraterm and Secure CRT, and bunch of other programs. Most of these programs works on Windows machines, but there are other programs also works on Linux as well as Mac OS. PuTTY, for example, do work on, there's a version for Linux as well. So these are like the the terminal programs that can be used to connect to your Cisco device. Let's look at the ways that you can navigate the Cisco IOS. The primary command modes include the user executive mode and privilege executive mode. The user executive mode allows access to only a limited number of basic monitoring commands, and it is identified by the CLI prompt that has this, symbol, this particular symbol. For example, it will have that symbol right here in the router or the switch. So this is the device name, and you have that symbol, and you start typing right on here. Privilege executive mode allows access to all commands and features. It is identified by the number symbol or this hashtag symbol, and you have that right here, and then you start typing over here. If you are configuring your device, you will be in the privilege executive mode. And you can secure privilege executive mode with a password and a username. With a password, and I will explain that later. The configuration mode and sub-configuration modes allow you to do different setups, different entries on your Cisco IOS device. The global configuration mode, which has this number sign, used to access configuration options on the device. The line configuration mode is used to configure things like SSH, Telnet, or aux access, such as it will allow you to configure that particular section of the configuration. You will see on your Cisco IOS console that you'll have the name of the device, and you'll have config-line, and then you have this pound or hashtag key, and that's where you do the line configuration. The interface configuration mode will have that if config-if as opposed to config-line, and it is used to configure a switch or a port interface. For example, if you want to open a port, you will say no shutdown, for example. You'll go, you will enter IP addresses for that port, for example. And how you enter this config-if is by going int, then you'll enter the switch port that you need to access. Again, I will do separate videos on demonstrations on how you can do all of these different modes and how you can navigate through them. And I will leave a link below in the description in this video, so you can go ahead and watch that. But just for now, just remember there are 3 different types of modes: global configuration, line configuration, and interface configuration. Next, we will look at how we can navigate between IOS modes. To go into the privilege executive mode, what you need to do, you will first log into your Cisco device, and you will end up a switch with this symbol. And you enter EN or enable. EN is the short form. I usually use EN, but you can use enable. That's a complete form. And you enter enable and then press enter. And it will get you from executive mode to privilege executive mode. To enter global configuration mode, what you need to do is to move in and out of that mode is to use the configure terminal command. To return to the privilege executive mode, you will use the exit command. So basically, you go enable, it will get into the switch. It will get into the privilege executive mode. And if you go exit out of it, you can exit back into here as well. But if you want go into configuration mode, configure terminal mode, you can go config T or configure terminal, and it'll get you into this one. So in this particular slide, it doesn't actually show you that. So I'm going to repeat that again. To get into privilege executive mode, you're going to go enable. If you want to exit out of it, you can enter exit here, and you'll get back to the switch main screen. If you want to go into the global configuration mode, after you enter enable, you enter configure terminal or config T and press enter, and it'll get you to the global configuration mode. To exit out of global configuration mode, you just enter exit, and then that will get you back into the privilege executive mode. To get into line configuration mode, what you need to do is to enter line console and then enter the line console number and then press enter, and it will get you to the line configuration mode. Again, in order to exit out of that, you can enter exit and press enter, and it'll get back into line console. And I know this can be confusing when you are a new student and you're looking at this slide and you're scratching your head like, oh, that's really confusing. But I will do is I will post a video with all these navigations so that you can get a better idea. And as you learn more Cisco IOS navigation and configurations, this become a second nature, and you'll be really fast at going back and forth between these modes, and you don't have to worry about it. But for this particular module, and if you are taking this course with Cisco, for quizzes, remember these three the different configurations and how to go in and out of it. Next, we'll look at the sub configuration modes. The sub configuration modes basically allow you to go in between different modes by entering into the CLI. To move out of any sub configuration mode and get back to the configuration mode, as always, it is always the key term is the exit, 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 and press enter. It'll get back you to where you are. To return to the privilege executive mode, directly from a sub configuration mode, you can use the end command or the CTRL-C on your keyboard. To move directly from one sub configuration mode to another, just type in the desired sub configuration mode into the command. In the example, for example, here they have the interface, it going from line console to the interface. So in this Cisco example, they first enter the line console, and in the lines console, after they do whatever they want to do, or they decided they don't want to change anything on line console, you can directly enter interface Ethernet and then go into the next sub configuration without exiting back onto the other mode. If you have the Cisco iOS courses registered, you will be able to watch these original iOS Cisco navigation videos directly from Cisco. But because some of you don't have that privilege of having that courses registered, I will post some videos on my YouTube channel later. Let's look at the command structure of Cisco iOS. The basic iOS command structure include the prompt, command, space, keyword or argument. What really important here is the keyword and the argument. The keyword is a term that specifies parameter defined in the operating systems. For example, in this example, they use the IP protocols. The argument is not something that is predefined. It is a value or variable defined by the user. But it doesn't mean you can enter whatever you want. There are some restrictions on what kind of variables that can be defined in the argument. For example, if I went show IP and then enter my name here, Sanuja, for example, it's going to give you an error, obviously. But it is not predefined in a way that the Cisco device doesn't know 192.168.10.5 until you enter it. But the device do know what is a ping, for example. Device do know what is show, for example. So the keyword is a specific parameter defined in the iOS system or iOS operating system. The argument is not predefined. It is a value or a variable defined by the user, but however, there are some limitations on what you can enter there. For example, like I said, it has to be ping hostname or a ping IP address. You can't just enter random stuff here. So that's not very clearly defined on this slide, but I'm just telling you that so that you know that. The iOS command syntax there are certain checks in there. A command might require one or more arguments. To determine the keywords and arguments required for a command, you need to refer to the command syntax. You can, just like mentioned in the previous slide, you can't just enter whatever you want. There are some limitations. There are some structures that you need to follow. The boldface text indicates the command and keywords that are entered as shown. And the italic text indicates an argument for which the user provides the value. So let's look at this table. That's what they are talking about up here. So for the next few slides, remember, whenever you see the boldface, like a bolded text, it is an indication of commands and keywords that you enter literally as shown. And the italics are the text that includes arguments which you have to supply different values. And this X square bracket indicates the optional elements and the arguments, and the braces indicates the required elements. And this indicates basically the different choices available within that optional elements, and spaces are used to clearly separate those parts into separate sections. So that's what we're going to do for the next few slides. So let's go ahead. So the command syntax provides the pattern or a format that must be used when entering a command. So basically standardize how we interact with Cisco devices, which make it easy for network engineers, students, and everybody to interact with these devices so that everybody on the same page. And in this example, we're going to look at the ping command. So the user enter the ping command, and then the argument associated with it, which is the IP address or the host name. In this case, the IP address is an IP address within your network that you're trying to ping from this Cisco device. In this example, for example, it could be like 10.10.10.5, or it could be like 192.168.8.10, for example. And another example of this would be like traceroute command. Traceroute command is a command built into the iOS, but the argument associated with it, in this case the IP address, is the destination of that traceroute device, and that is defined by the user. In this case, it's traceroute 192.168.254.254. We'll do a traceroute using this Cisco device to that 192.168.254.254 device. If a command is complex with multiple arguments, you may see it represented just like this. For example, switch port, port security, aging will have multiple variables that you can enter, static, the time, the type, etc., etc. In this course, you will not be learning about switch port security as of yet. So just remember, some complex commands are available on Cisco devices to do certain things. If you don't remember some of the commands, there are some help features available on the iOS. You don't have to memorize everything, but you need to know what all of those commands do. But even if you forget what they do, there are some helpful features built into the iOS. So there are two forms of help variables: the context sensitive help and command syntax check. The context sensitive help enable you to quickly find answers to these questions. For example, which commands are available in each command mode? Which commands start with a specific characters or group of characters? Which commands which arguments and keywords are available to particular commands. For example, ping command have multiple arguments, and you can enter ping and then the question mark, and it'll give you some information about what you can do. For, like I mentioned, it's not just, you can not only ping an IP address, but you can do also a host name. And if you forgot that, right, if you weren't sure about that, you can do ping question mark, and it'll give you that information saying, hey, you can use the IP address or the host name. The command syntax check verifies that a valid command was entered by the user. So what it does is, the Cisco IOS has a built-in interpreter, and that interpreter try to understand the command that you entered, and it provides sometimes very valuable feedback describing that there is something wrong with it. Like for example, in this particular command, this user have entered interface fast Ethernet 01, and it has this arrow right here showing that something went wrong, that there's something incorrect right here, please check. So that can be helpful when you enter a command and there was a mistake in it. Next, we will look at hotkeys and shortcuts. The iOS CLI provides hotkeys and shortcuts that make configuring, monitoring, and troubleshooting easier. And I use these shortcuts all the time. It makes it faster, easier, and it saves some time. The commands and keywords can be shortened to a minimum number of characters that identify a unique section. For example, configure command can be shortened to conf, because configure is the only command that begins with conf. I always use the conf t, for example, to enter configuration terminal, and that's what is shown here right here. It's conf t, and it goes to configuration terminal. The hotkeys and shortcuts can be completed using the tab. So you can enter conf and hit tab, and it will auto complete the rest of the command. Even though you do not need to do that in order to enter that command, you can just go conf t and press enter, it'll go forward. But you can do conf tab and t tab, and it'll give you like configure terminal, and then you can press enter. The backspace erases characters to the left of the cursor, just like any other operating system, just like Windows or a Mac. The left arrow or CTRL-B moves the cursor one character to the left. So if you are in the middle of entering a command, for example, if you are entering, conf t and you enter M by mistake here for something, you can go back here and then change that letter in this case. And the right arrow do the opposite of that. It moves the character to the right. And up arrow or CTRL-P recalls the command in the history buffer beginning with the most recent command. This is a really helpful time-saving thing that I do when I configure Cisco devices. So basically, if you're entering the same information, for example, IP address, and you're entering the IP address on multiple interfaces, you can simply go up and down arrow, and you can go to the previous command and just delete the IP address only, and then enter it, the new one, and then press enter. So that will give you an easy way to move up and down without re-entering the similar commands over and over again. And again, I will show you a video demonstration on how you can go about doing these things, but not in this particular video, but it will be a separate one. And when a command output produces more text than that can be displayed on a terminal, because terminal window may be too small, the iOS will display the term more. It's a prompt to the user, and the table below describes the keystroke that can be used when that prompt is displayed. So if you see, if you enter something like, for example, do show run, which will have lots of information about your entire running configuration, it'll have this thing on the bottom saying more. If you hit enter key, it will display the next line. So it'll move to the next line. But if you hit the space bar, it'll display the next entire screen. So it will move from one screen to the next screen. If you enter any other key, it ends the display string and return to the privileged executive mode. The table below also lists the command that can be used to exit out of that kind of operation. So CTRL-C when any configuration mode, it ends the configuration mode and returns to privilege executive mode. So if you are in a configuration mode, you are configuring a port, for example, and you want to exit it, you can do Control C and it'll exit out of it. Control C is whenever you are in any configuration mode, it ends the configuration mode and returns to privilege executive mode as well. And Control Shift 6, it's an all-purpose break sequence that used to abort like a DNS lookup, traceroute, and ping. So let's say you decided to ping a device and it's taking way too long to ping, and you decided, you know what, that device is not working, I need to move on. Because the Cisco iOS is trying to ping and is still sending those ICMP ping packets, the only way you can exit out of that is to enter CTRL Shift and number 6, and it'll get you out of that. And I will go through all these shortcuts and everything in my demo video that I'll be posting later. So don't worry about that too much. But remember that there are these multiple hotkeys and shortcuts available, and I will post a video later to show those shortcuts so that you have a better idea about how to use them. Next, we will look at the basic device configuration. The device names are names that can be used to identify your iOS device on a network. The first configuration command on any device should be to give it a unique host name. Not only give a unique name so you can identify them, you can actually use them to ping it as well for like testing connectivity. By default, all devices are assigned a factory default name. So on all iOS switches, it will say just switch. So the guideline we give for typically naming a device: start with a letter, contain no spaces, end with a letter or a digit, and only use letters, digits, and dashes, and be less than 64 characters in length. For example, this guy started with switch, and he went into the configure terminal, and he went host name and enter a host name for that device. It's called SW-floor-1. It makes sense. It's basically saying this is a switch on floor 1. And now this switch name, the host name has been changed from switch to SW-floor-1. Now to return the switch to the default prompt, you can use no host name, and that will actually delete whatever the host name you entered. Whenever you are setting up a Cisco device or simulating a Cisco device on a Cisco packet tracer, or emulating it on the EVE-NG or some other software, I would highly recommend that you change the host name first before moving on to doing anything else. It'll make it easier for you to identify the device when you have multiple devices and multiple terminals open. In terms of password guidelines, the use of weak or easily guessed passwords are a security concern in a production environment. But even in a lab environment, get used to using complex passwords and so that you are always, used to having that complex cities in passwords. All networking devices should limit administrative access by securing privilege executive, user executive, and remote telnet access with passwords. In addition, all passwords should be encrypted, and legal notifications should be provided. Basically a message when somebody try to enter your device. Password guidelines are typical guidelines that we give for many components on any network. Use passwords that are more than 8 characters in length. Use combination of upper and lower cases letters, numbers, special characters, and or numeric sequences. Avoid using the same password for all devices. Like don't use like same password, for example, Canada on every single thing. Instead, use different passwords for different devices. Do not use common words. They are easily can be guessed. just like I mentioned, if you're in Canada and you put Canada as a password, that is a pretty bad password. But in lab environment, when you are working with Cisco modules, and if you're registered for a course, most of the passwords are very simple. Typically, it is Cisco or class. And these passwords are considered extremely weak and easily guessable, but it should not be used in the production environment. So it is okay to use in the lab environment, but do not use in the production environment. As you go through the learning process, I actually recommend using stronger passwords so you get used to using it even in the lab environment. To configure password, you have to enter the password for a couple of items. So first look at securing the user executive mode access. First, enter the line console configuration mode using the line console 0. The line console 0 is the configuration mode for that user executive mode. Then you can specify the password by entering password and then whatever the password you need to enter. For example, on the right hand side, you see this guy went into configuration terminal, line console 0, and then password, and then he entered the password he would like to have. So in this case, the password is going to be Cisco. Then you enter login and end. Make sure you enter this command login, so that will actually enter that password into the system. And now you will have that Cisco as the password for configuration terminal. To secure the privilege executive mode, first you need to enter the configuration mode, the global configuration mode. Next, use the enable secret and then enter the password. So what you do is config T or configuration terminal, and you go enable secret, and then your password going to be, in this case, class. And in this case, instead of going to login, you're going to press enter exit and enter. And that will register class as the privilege executive mode password. Again, I will demonstrate this on a different video so you can have a better idea about how to navigate through these steps. To secure VTY lines, what you need to do is you need to go and access the configure terminal and then enter the VTY line configuration mode. To do that, typically we use the line VTY 0 to 15 command in the global configuration mode. Then we can specify the VTY password using just like before, just password, and then you can enter the password you would like to use, in this case Cisco. And remember, in this case you have to enter login so that it will register that password, and then you can end, and that will give you the line VTY access password. Please note the VTY lines enable remote access using Telnet or SSH to the device. Many Cisco switches support up to 16 VTY lines that are numbered 0 to 15. However, if you have more than 15, what you do, more than 16, I mean, what you do actually, you go line VTY 020 or 024, etc., etc. That will encompasses all the line VTYs that you need to encrypt that password. So not enter that password for. Next, we will look at the encrypt passwords. So for encryption of password, we need to understand that the startup config and running config files displayed passwords in plain text. But by using Cisco built-in encryption, you can hide that plain text. To encrypt all plain text passwords, use the service password encryption global configuration command. So how it works is basically you log into your Cisco iOS device and then move into the configure terminal and just enter service password -encryption and press enter. And that will encrypt all the password within this device. Then if you use the show running config command, you will see that the passwords on this device are now encrypted. Please keep in mind the Cisco IOS uses the same encryption algorithm to encrypt these passwords, and these are actually not really secured if somebody were to copy these numbers and reverse engineered back the password. So this is just to prevent someone from just accessing your iOS device and just reading out the passwords based on the displayed information, but they are not highly secured. Like, if somebody were to give these numbers and characters and they use the reverse engineered Cisco iOS encryption algorithm, they can reverse engineer the password. So these are just to prevent people from quickly reading the password, not necessarily like preventing a hacker or something. Next, we're going to look at the banner message. So what's a banner message? A banner message is an important message that can be displayed on the terminal to your user. So it basically warns unauthorized personnel from attempting to access the device. And when somebody try to access the configure terminal, they will get that message. For example, authorized access only, for example, in this here, the shown on the right hand side. So to create a banner message, what you need to do is to use the banner message MOTD and then enter the message between the pound symbols in the global configuration command. The pound symbol in the command syntax is called a delimiting character, and it is entered before and after the message. And in this example, this user enter the configuration mode and when banner MOTD and put that pound symbol and put authorized access only and put the pound symbol in the back end so that the system knows the message has ended, and press enter, which will result in this message displaying when somebody try to enter the configuration mode, and it will give you authorized access only. You can enter whatever the numbers or letters you like, and the banner message can be multiple lines and can contain lots of information, or it could be a simple line like just authorized access only. Next, we're going to look at how you can save all these configurations you just did on your packet tracer or on your Cisco iOS device. The configuration files can be divided into a couple of different categories, and there are two system file categories or files that stored the device configuration. The startup config is the save configuration file that is stored in NVRAM, and it contains all the commands that will be used by the device upon startup or reboot. Flash does not lose its contents when the device is powered off. In other words, that is where the kind of a permanent data is stored in the startup config. The running config is stored in the random access memory or RAM. It reflects the current configuration or whatever the configurations you just entered into the Cisco iOS device. Modifying a running config affects the operation of the Cisco device immediately. However, the RAM is a volatile memory. If the device loses power, it loses all the configurations that you just entered to the RAM. So it is important when you are configuring something that you always save it on the startup config when you have something working and working correctly on your running config. When I'm setting up any Cisco devices, I enter my configurations, especially complex configurations, and then I'll see if it works before I go ahead and enter into the startup config. Because with the running config, you can always delete it, erase it by just disconnecting the power to the iOS device. To save changes made to a running configuration to the startup configuration file so that it will be available and saved on the device, what you need to do is just type the command copy running config startup config privilege executive mode command. Like for example, in here, show startup config will show all the startup configurations, and this will make sure that your running configuration commands are saved onto the startup config. To alter the running configurations, you can do a couple of things on your iOS. If changes are made to the running config do not have the desired effect, in other words, you enter something that is incorrect or wrong IP address or something went wrong, as long as that has not yet been saved, you can restore the device to its previous configuration by doing a couple of things. One of the things you can do is to remove the change commands individually, or you can reload the device using the reload command in the privilege executive mode. But please keep in mind, this reload command will cause the device to briefly go offline and leading to a network downtime. It's just like pulling a power out of the iOS so that you get everything reset. If the undesired changes were saved to the startup config, it may be necessary to clear all the configurations using the erase startup config command in the privilege executive mode. And to do that, basically use exactly that, the erase startup config. And after erasing the startup config, reload the device to clear the running config file from the RAM. And that will get you back into where you were before. Next, we will look at capture configuration to a text file, like how you can capture the configuration to a text file. The configuration files can be saved and archived to a text document. Because Cisco IOS uses the CLI, it basically interprets your text command to configure their devices. You can literally copy and paste those configurations from one Cisco iOS device to another, as long as those are compatible devices. To copy to a text document, you can open the terminal emulator software such as PuTTY or Teraterm that is connected to a switch, enable the logging into the terminal software and assign a name and a file location to the save the log file. The configure displays all the sessions output will be captured to the file specified. So in other words, it will go and save in that log file right here. So on the right hand side, it'll show you how you do it in PuTTY. On Packet Tracer, you can simply go do show run and highlight everything and copy and paste it to a text file when you are doing your emulated labs. But when you are using simulated labs such as EventG or actual device, you had to use the PuTTY to save those text files. And the next step we're going to do is execute show running config or show startup config command at the privilege executive mode, and the text in displayed terminal window will be placed into that chosen file. So only thing you do is that set up the file name and choose the location, and on the terminal you run the show startup config and it'll get saved in there. To disable logging in the terminal software, basically on the right hand side you will show you change this option, this session logging, to none. So if you go back, we had the session logging as all session outputs, and we're going to say none to stop it from saving those text files. The text file created can be used as a record of how the device is currently implemented. The file could require editing before being used or restore a saved device configuration. So in other words, like you can use this file to save your implementations, and if it actually works, you can actually copy those commands to your next device as well. Let's look at ports and addresses. IP addresses. So what are they? So IP addresses is a type of addresses that are used to communicate between network devices. So the use of IP addresses is the primary means of enabling devices to locate one another and establish end-to-end communication on the internet or internal networks. The structure of an IP address is called the dotted decimal notation, and it is represented by 4 decimal numbers between 0 to 255. This is specific to IPv4. An IPv4 subnet mask is 32-bit value that differentiates the network portion of the address from the host portion. Coupled with the IPv4 address, the subnet mask determines to which subnet the device is a member. I will not go into depth about subnet mask and how subnet works and how IP addresses are created in IPv4. We will look at subnetting and how these are done on a separate video. It will require like a couple of minutes of explaining and in-depth analysis. Otherwise, if you are new to network engineering and network system, if you are a student, it will be a little bit harder to comprehend what is a subnet mask. So I will do a separate complete video on that, and I'll post a link below. But for now, just remember IPv4 has a subnet mask, which is a 32-bit value, which is right here. This is a 255.255.255.0 for this address 192.168.1.10. And then finally, we have the default gateway address, which is the IP address of the router that the host will use to access remote networks, including the internet. So basically, the default gateway is the guy who allows routing of messages, the packets, between your Cisco device or the end device and the outside world or other devices. IPv6 addresses are 128 bits in length and written as a string of hexadecimal values. Every 4 bits is represented by a single hexadecimal digit for a total of 32 hexadecimal values. Groups of 4 hexadecimal digits are separated by a colon. So this is an example of a IPv6 address. Again, I will do a separate video on how IPv6 addresses are done. And for now, just remember that has 128 bits in IPv6, and in IPv4 we have 32 bits. This will show up on quizzes with the Cisco NetAcad Academy or a Cisco exams that you will be taking with this particular course. So remember, IPv4 is the 32-bit version, and IPv6 is 128-bit version, and it has more addresses than the IPv4. The IPv6 addresses are not case sensitive and can be written in either lowercase or uppercase when there are letters involved. Remember, IPv4 don't have letters, IPv6 do. So it has to do with the fact that it is 128 bits. You just need to remember the hexadecimal and how it works. I will explain that later on a different video. Note, IP in this course refers to both IPv4 and IPv6 protocols. IPv6 is the most recent version of IP and is replacing the most common IPv4 as we move forward with multiple devices being used globally. And this slide doesn't explain the reason why we have IPv6 is that we have pretty much ran out of IPv4 addresses right now for global use. Interfaces and ports. Network communications depend on end user device interfaces, networking device interfaces, and cables that connect them. Types of network media include twisted pair copper cables, fiber optic cables, coaxial cable, or wireless. As we mentioned in module 1, all of these types of cables can be used when you are communicating from your home to the internet. Different types of network media have different features and benefits. Some of these differences between various types of media include the distance the media can successfully carry a signal, such as a fiber optic cable can carry a long distance a signal without degenerating it compared to a metal wire. Environment in which the cable is to be installed. The copper cables are more rigid, but like more versatile compared to fiber optics sometimes in certain environments. the amount of data and the speed at which it must be transmitted. Fiber optics has a much higher bandwidth and data transmission capabilities compared to copper cable and metal wires. And the cost of the media and the installation. The installation process of copper cables are much easier, and the cost is far less for both materials as well as the labor. Compared to fiber optics, the material and labor costs are much higher. Let's look at how we configure IP addressing. Manual IP address configuration for end devices is not something that typically used on most end devices, but they are used in devices such as servers and those critical infrastructure that requires a static IP address. Typically, the servers containing services such as web services and email services, for example. The end devices on the network need an IP address in order to communicate with each other, on the network. So IP address is like your home address. By knowing by knowing your home address, I would know where you live on a Google map, for example. IP address does exactly the same thing, but for network devices. IP4 address information can be entered into end devices manually or automatically using Dynamic Host Configuration Protocol or DHCP. To enter manually IPv4 on a Windows machine PC, most people know, familiar with the Windows operating systems. You basically go to the control panel, network sharing center, change adapter settings, and choose the adapter settings, just like here shown on the right hand side. Then you click on the properties, open the internet protocols, and then in there you can select what you need to do for IPv4. You can do the same thing for IPv6 as well, and that's how you do it on a Windows machine. Typically, these Windows machines are set on the obtain an IP address automatically, which basically doing is that they are using DORA, which I explain later on in this course, to go and request an IP address from a DHCP pool and just hooking up into the network that way, so that the end user doesn't have to do any of these configurations. So that's what we're going to talk about next. So the automatic IP address configuration for end devices are done through something called the DHCP. DHCP stands for Dynamic Host Configuration Protocol, which enable automatic IPv4 address configuration for every end device that is DHCP enabled. So by switching this from using the static to automatic, and also the DNS, you can either put the static or automatic, it'll obtain not only DHCP IP address, it can also obtain the DNS from the same server. The end devices are typically by default set to DHCP for IPv4 configuration. And again, the same place that we went to change the IP configuration on Windows machine is the same place you go to switch this from the manual to DHCP. And please note the IPv6, however, uses something called the DHCP v6 or SLAC, which is a stateless address auto configuration for dynamic address allocation. Just remember for your exams, DHCP use a DHCP server to hand out IP addresses automatically to IPv4 devices. The DHCP v6 and SLAC or stateless address auto configuration is used by IPv6 devices to obtain the similar automated IP addresses for their end devices. Switch virtual interface configuration is the one we're going to look at next. So to access the switch remotely, an IP address and subnet mask must be configured on the SVI or the switch virtual interface. To configure an SVI on a switch, what you enter the interface VLAN1 command in global configuration mode. Next, assign IPv4 address using the IP address. and then the user input associated with it. Like for example, in here, on bottom, you see that they're in configuration terminal mode and interface VLAN 1, and then you go IP address, then you enter the IP address and the subnet mask. In this IP address, it's 192.168.1.20, and the subnet mask of 255.255.255.0, which is associated with this IP address. And then you go no shutdown. What the no shutdown command gonna do, it's gonna enable that interface VLAN 1, which by default will be disabled. Finally, we have come to the end of this module, and I will quickly go over what we learned in this module. For those of you who are registered with Cisco NetAcad or with an organization to do these particular courses to obtain your badges and certifications, these are the key things that you need to remember for your quizzes and exams. In this module, we learn all end devices and network devices require an operating system known as, in this particular scenario, iOS, because we are using Cisco devices. The Cisco iOS software separates management access into couple of categories, 2 categories: user executive mode and privilege executive mode. You should know how to enter them and how to exit them, and what commands can be used on some of them, like basic commands that we just went over. Global configuration mode is accessed before other specific configuration modes. From global configuration mode, the user can enter different sub-configuration modes, such as line VTY, for example. Each iOS command has a specific format or syntax and can only be executed in the appropriate mode. So you can just go and enter random things at random places. It will give you an error message, and some of these error messages are very helpful. So you need to make sure that the specific format and syntax is followed. Basic device configurations such as hostname, password, encrypt passwords, and banner. We just went over how to do that. There are 2 system files that store the device configuration: startup config and running config. And you should know how to go about saving your files into startup config from the running config. IP addresses enable devices to locate one another and establish end-to-end communication on the internet or within a network. Each end device on a network must be configured with an IP address, either IPv4 or IPv6, otherwise it cannot communicate within your network. That's everything for today for this module. As I mentioned before, I will post a bunch of videos showing some configurations which I will do on Cisco Packet Tracer that will cover the items that we covered in this particular module. That will give you a better idea of how to use these commands and configure iOS devices. Please subscribe and thumbs up this video, and I will post future videos for next few modules within next few days to weeks, so that you will have the complete set of videos for this particular course set. Until next time, have a nice day.